Hi, stats enthusiast. Welcome to another lesson in our AP Statistics series for Unit 6, Inference for Categorical Data, specifically proportions. In today's lesson, we are going to be conducting a significance test for a proportion and also learning how to use the TI-84 commands to conduct a significance test for us. This is specifically for Notes 4, which is going to be conducting a significance test for proportions. So go ahead and grab your notes, get settled in, and we're going to dive into our content today. Before we get into running a significance test today, I want to go over a couple of important notes from the last video. So remember that a p-value is a conditional probability. It assumes that the null is true. And when we assume that the null is true, the p-value measures how likely it is to get evidence for our alternative by chance alone. So interpreting the p-value is going to be a skill you have to know how to do. And not just the conclude part of the test, but actually interpreting what a p-value is. And a p-value is the probability we get a p-hat value given our null or our claim is true. You have to make sure that you name the test either by writing it down or by writing down the generic Z formula. You only have to do one to get full credit on the AP exam, but you'll see that I end up doing both of them when I conduct a test just to cover all my bases, right? So we have a one proportion Z test that we are going to cover and see an example of today. For a hypothesis test or significance test, we check to see if n times p naught is greater than or equal to 10 and n times 1 minus p naught is greater than or equal to 10 for our large counts condition. For confidence intervals, we use p hat. And the reason for this is because in a significance test, we are centering our sampling distribution around p naught. We are assuming that the null is true, so our center is around p naught. And because our center is p naught, we want to create a shape and make sure that it's a normal distribution when our center is p naught. For a confidence interval, we use this for our large counts because that p hat was our point estimate. And p hat being our point estimate means it's in the center of our confidence interval, and we create a margin of error around it. So because our sampling distribution has p hat at the center, we use the large counts condition for p hat in confidence intervals. So that is an important distinction. You will get it incorrect if you interchange those. Okay. If you accidentally use p hat instead of p naught or somehow vice versa, it will be incorrect. So make sure you keep that large counts condition straight. It depends on which inference procedure you are using, confidence intervals or significance tests. And then we also say when there's not convincing evidence to reject the null, it does not mean that there's evidence that the null is true or that the alternative is false. Okay? We just don't have enough evidence to reject the null. It does not give us information about, oh yeah, the claim is for sure true or the alternative is for sure false. We just didn't find evidence for it. And this conclusion becomes a little bit more clear in the next set of notes when we talk about errors and power of a significance test. Right now, I want to actually conduct a significance test. So I'm about to go through the 4 steps. I did go through this in the last video, so I just want to do a quick recap here of the things we have to include to make sure that we are communicating our ideas efficiently when we conduct a significance test. We want to, for the first C, communicate, define P equals in words, identify the hypotheses we are testing, and write down our significance level. Our conditions, random, independent, and normal because we are creating a sampling distribution. And please don't forget, the large counts condition is going to be checked with our null proportion, our claimed proportion from our hypotheses. Our calculate, we're performing a one proportion z-test or a one sample z-test for a proportion, whichever way you prefer to write that. We calculate our test statistic by taking our statistic minus our claimed proportion and we divide it by the standard deviation of our claimed proportion. Now, I say standard deviation of our claimed proportion because, again, we create our sampling distribution around P naught, and so our center is P naught, and then our standard deviation has to be based off of P naught. So we calculate Z, and then we find our p-value by finding the probability we get this Z statistic, or more extreme, and we use normal CDF for that, okay? Like we have always done with Z-scores. And then in our conclusion, we have two sentences that we are going to use. I said the first sentence is our statistical conclusion. Because our p-value is smaller than our significance level, we reject or fail to reject. And then our second sentence is our conclusion in context, whether we do or do not have convincing evidence that our population proportion, and then we go in to explain what our population proportion is and basically communicate our hypotheses again in context of the problem. So we'll see how to do all of these things with an example today. So this is our one example for today. A complete one sample Z test for a proportion. So our friend Alan reads a report that says 80% of US high school students have a computer at home. He believes that the proportion is actually smaller than 0.8 at our school. So Alan is going to choose an SRS of 60 students, and he's going to record whether they have a computer at home. He wants to test this at the 5% significance level. In his sample, 41 of the students have a computer at home. Is this evidence that the proportion of students who have a computer at home at our school is less than the national proportion? Whew. Beautiful, beautiful, beautiful problem. So when you look at a problem and you look at a blank sheet of paper and you're like, what the heck do I do? You need to think of those 4 C's. Always start with the 4 C's. First, start with the communicate part, okay? And think, okay, what pieces do I have to communicate this problem, that I understand this problem? The first one, you want to make sure that you're communicating your proportion in context. P is the proportion of students who have a computer at home. That is what you are measuring. So we want to communicate P in words. The next piece is our hypotheses. And what I'm going to set up here is our null is equal to that national proportion. We're going to assume that our school follows that national proportion, that 80% of students have a computer at home. What Alan believes is that it's smaller than 0.8 at our school. And because he believes it's smaller than 0.8, our alternative is going to be less than 0.8. If Alan wasn't sure of which direction, if he just wanted to test to see if it was different than 0.8, it would be a two-sided. But this is a one-sided because he believes it's going to be smaller than 0.8, and he sets that before he conducts an SRS. We can also use this opportunity to communicate a few other details of the problem. We do have to communicate what our significance level is, and in this case it is 0.05. Our sample size is 60. So you can write that down just so you have it and are kind of organizing the information from this word problem. The other piece of information we are given is p hat. So remember, p hat is our sample proportion. So we're going to take 41 divided by 60. So 41 out of 60 students had a computer at home, which gives us the p hat value of 0.683. So again, the whole point of this test, right? If this is the national average and we ended up getting a sample proportion that's less than by this much, is that difference going to be significant? Is it significant enough to say that, is there evidence enough or significance enough that the proportion of students who have a computer at home is less than our national proportion? Okay? Is this evidence? Did we find evidence here between this difference? That's communicate. Next up, we want our conditions, our 3 conditions that we know and love for proportions. Random. He took a random sample. An SRS was stated in the problem. He is good. That is checked. Independent is our 10% condition because he sampled. So 60 is less than 10% of all students at our school. That is good. Perfect. Independent condition is met. And our last one is our normal condition. And I used P naught here, okay, 0.8. So n times p naught is greater than or equal to 10, and n times 1 minus p naught is greater than or equal to 10. And I just set up those inequalities. You can solve them and show that they are true, but you want to communicate that you checked them. And in this case, they do check out. And because all three of those conditions are met, we can create a sampling distribution and find this probability. So in our next step is our calculate step. I want to write down what inference method I'm using. I am running a one proportion Z test. And I also just decided to write down the generic formula. Now I say the generic formula because on the AP exam in AP statistics, you are not given this formula. You are given the skeleton of a Z statistic, but you have to piece it together. So by writing down this specific formula, you are identifying, okay, I am running a one proportion Z test. And we're going to plug in our values. Okay, our p hat value of 0.683, our p naught value of 0.8, and then we put that in our denominator 0.8, 0.2, and then our n value of 60. So I show those values plugged into my formula. You don't have to show any algebra on your paper, but I mean, by all means do it if you want to write down your algebra. But you find your Z test statistic. And I got negative 2.27. Next up, we find the probability, right? Our alternative was less than. Our alternative hypothesis, if you look back at your paper, copying down the notes, our alternative was less than 0.8. So because of that, that's what our inequality is going to be when we find the probability that Z is less than negative 2.27. Now, you are definitely welcome to draw this curve if you would like. It's a standard normal curve, negative 2, it's probably a little farther out than that, but we're finding this area right here. This is our p-value. You do not have to draw the curve though. It is not required on the AP exam. It is just a visual if you are a visual kind of person and want to draw that in there. That is the p-value we are trying to find. On our calculator, our lower boundary would be negative infinity. Our upper boundary would be negative 2.27. Our mean is 0 and our standard deviation is 1 because we are working with the standard normal curve because we found a Z-score. And that gives us our p-value of 0.0116. 4 significant figures is plenty here. You don't have to go any more than 4. 0.0116 is our p-value. And that's all you have to do for the calculate step. All you have to do for a calculate. Next, and finally, is our conclude step. We have to make sure that we can conclude this test and determine what we found. So first is our statistics conclusion. There's no context to this. It is just our statistics conclusion. We say because our p-value of 0.0116 is less than our significance value of 0.05, we reject the null hypothesis. Okay. So remember when your p-value is less than alpha, you reject. That is your conclusion. When your p-value is higher than alpha, you fail to reject. Okay. Those are your two conclusions. It won't be equal to alpha. That would be very unfortunate if you were given a problem that was equal to alpha. It'll never be equal to alpha in the problems that you see in AP statistics. It will always be less than or greater than. I guess if it was equal to alpha, you would just have kind of an inconclusive result, which wouldn't be super satisfying. So your p-value would either be less than alpha or greater than alpha. Because it's less than alpha, in this situation, we reject the null hypothesis. And again, no context to that. And we need context. So that's what the next sentence is for. Because we reject the null, that means we do have statistically significant results. Or we say we have convincing evidence that the true proportion of students who have a computer at home is smaller than 0.8. So we have convincing evidence that, and then this is our context. And because we have convincing evidence, we usually summarize it by communicating what the alternative hypothesis is. So we have convincing evidence of the alternative. Okay? We have convincing evidence of the alternative, and that sentence is communicating what the alternative is. The true proportion of students who have a computer at home is smaller than 0.8. If we do not have convincing evidence, we would say we do not have convincing evidence of the alternative in context. All right, and that's our test. That is the full test. That is all of the parts you are going to want to show on the AP exam. The next part, part B, I just want to check the solution using the TI-84 because you are able to use this on the calculator. And especially if it's a multiple choice problem, we want to not have to worry about showing all of that work on a multiple choice problem. We want to be able to jump and make sure we can use our technology. So if you use the TI-84 or TI in some way, it all kind of looks approximately the same. You're going to go to the test section down to number 5. It's called the 1 prop Z test. And what you are going to enter is your P0, your claimed proportion. X is the number of successes, and N is your sample size. So you're not entering a p-hat value. You have to enter in number of successes and your sample size. So we would enter 41 for X and 60 for our sample size. And then we have to choose our alternative hypothesis. And there's 3 choices right here. So you can see in this specific example, I highlighted less than P0 because our alternative was less than our claimed proportion. Okay. And when we do that, these are our results. So we get our Z value. Okay. And you'll notice it's a little different from what I got by hand, right? Very similar. A little bit different because our p-hat value, when we took 41 divided by 60, our p-hat value is going to be, it's actually reported right here, a repeating decimal. And because of that, you are going to get a bit of a rounding error when you do it by hand versus the calculator. But that is okay. The AP examiners who grade, they do expect subtle differences like this. So on a free response question, they would accept either, whether you did it by hand or checked it and just used the numbers from the calculator. On a free response question, on a multiple choice question on the AP exam, this would not be an issue. They would make sure that either rounding wasn't going to give you a different answer or rounding was going to give you a negligible difference to where you didn't have to discern between choice B or choice C just because of rounding, right? Because it also gives us our p-value that was also slightly different. We had 0.0116 and this gives 0.0119, but we come to the same conclusion. All right, and then the last thing I snuck in here, when you run a significance test, you don't have to interpret the p-value in the context, but interpreting the p-value in the context of the problem is an important thing you need to know how to do. Okay, so this usually isn't part of the test, but you will be asked to do this at some point. Absolutely. So here's the interpretation in our context. We say if the true proportion of students who have a computer at home is 80%, so if our null is true, right? And that's the context with it. If our null is true, the probability our sample has 41 or less out of 60 with a computer at home is 0.0116. So the interpretation of our p-value is if our null is true, the probability, this is kind of like the template, we get the p-hat value or more extreme is, and then that p-value, okay? So p-hat or more extreme is 41 or less out of 60, because we look at 41 out of 60 was our p-hat, or less was the more extreme in the direction of the alternative. Okay? So make sure you can interpret p-values in the context of the problem. And that is your significance test. And that wraps up today's lesson on conducting a significance test for a proportion. In the next set of notes, we are going to be going over errors and power of a significance test. It's a favorite lesson of mine, so you're definitely going to want to make sure you tune in. If you enjoyed this video, please go ahead and click the like button and subscribe to my channel for more great AP statistics content. I wish you endless statistical success, and I will see you in the next video.